Ladies and gentlemen, welcome to It's Rainmaking Time. Today is a day for subject matter that is very complex and very important to most people around the world and certainly in the United States. Today is a conversation about our grid. It's a conversation about geomagnetic storms, the condition of our magnetosphere, and how it is that electric power is impacted by space weather. And there's really nobody better to talk about this than John Kappenman. John Kappenman has been an active researcher in power delivery technologies, and his engineering contribution has been his research work on lightning, magnetic storms, and their disruptive effects on electric power systems. He's led a utility industry effort to deploy a monitoring satellite that now provides advanced warnings of geomagnetic storms launched by NASA in August of 1997. He's a collaborator with EPRI and Global Atmospherics on the development and application of the fault analysis and lightning location system that will allow economic location-centered mitigation of lightning to transmission networks. He's a senior member of the IEEE and the Power Engineering Society and is the past chairman of the Transmission and Distribution Committee. He currently serves as the instructor at the University of Minnesota Duluth Department of Electrical and Computer Engineering, and has served a number of times as a faculty member on the University of Minnesota short course on EMTP. He's published over 30 papers in a variety of subject areas. He is the recipient of the IEEE Walter Fee Outstanding Young Entrepreneur Award, the IEEE Prize Paper Award, the Westinghouse Nicholas Tesla Award, and 2 EPRI Innovative Awards. He is also heavily involved in making presentations to the U.S. President's Commission on critical infrastructure protection, on the potential impact of geomagnetic storms on electric power system reliability, and has served as an invited lecturer at the International Space University on space weather and impacts on electric power systems. He has been appointed to the ongoing committee and was one of the lecturers at the NATO Advanced Science Institute on space storms and space weather hazards that was held in June of 2000. Ladies and gentlemen, welcome John Kappenman to It's Rainmaking Time. We obviously have somebody very heavy-hitting in the space weather and the geomagnetic electrical energy universe. Thank you so much for being here and taking your time today to educate the public.
Thank you, Kim.
You're involved in EMP, which is what? Electromagnetic pulse. Is that what it is? What is it?
That's correct. What it is it's caused by a high-altitude nuclear burst, and it produces both a very high-speed transient signal, which can disrupt sensitive electronic systems, as well as a disturbance to the Earth's magnetic field that is similar to that caused by naturally occurring geomagnetic storms.
So is EMP understood as being something that's intentional, or is it also something from space?
No, it would be an intentional act carried out by perhaps a group of terrorists that have access to a nuclear weapon. It could be carried out, of course, by a rogue state or nation state as well. Even attempting to defend ourselves from a nuclear attack, as in missile defense, could cause an EMP burst in that if we shoot down a nuclear weapon while it's in flight to us, it could explode and, in effect, produce the conditions for setting up an electromagnetic pulse as well. In the previous Cold War days, EMP was thought to be the first round of an attack that would occur. In other words, if the Soviet Union was about to attack the United States, they would launch a number of bursts that would be EMP bursts with the idea of trying to take out as much of the ability of the country to respond as possible, and then follow that up, of course, with reducing everything else to rubble. The Cold War is now over, and supposedly that threat of multiple warhead attack no longer exists. So Now the threat is one of just a country that has a single or a limited number of nuclear devices and wants to attack and inflict the maximum possible impact to society as possible, and that would be perhaps best carried out as an EMP attack.
My question to you post-Katrina, some of what we learned from Katrina is there was a window of time, an opportunity where we knew that those bags should have been protecting the levees.
Yeah.
And there was a lot that went on about it in terms of politics and management, but the fact is that it wasn't prepared. And then it ended up costing, I don't know, hundreds of millions or billions of dollars because we didn't do what we needed to do during the time that there was available. Aren't we kind of sitting on an exponential Katrina situation to not be dealing with this?
Very, very much like that. It'd be much bigger in scale. In fact, recent articles that have been written have talked about a space-weathered Katrina or a cosmic Katrina sort of event. The analysis that we carried out for FEMA indicated that the impact to the country potentially could span from coast to coast. It could take down the power grid. And the most disturbing aspect of this is that unlike other major power grid collapses that we have had before, if you remember the August 2003 blackout, the recovery from that was typically only a couple of days. In other words, they got the lights back on and things pretty back to normal functioning within just a couple of days after that blackout had occurred. What is unique about space weather or EMP is that the nature of this electromagnetic attack on the power grid infrastructure could cause massive permanent damage to a lot of vital and critical high voltage transformers on that power grid. And as a result, we may not be able to rapidly recover from this sort of blackout. The blackout could persist arguably for maybe years. And in the case of a geomagnetic storm, a severe geomagnetic storm, this arguably could be a planetary event as well, so that modern industrial societies throughout the world could be heavily impacted. And we would be put into a situation of how to respond to this that we're not very well prepared for. While we know that hurricanes can cause lots of damage, and we've experienced those often enough to understand that damage typically only occurs a few counties inland from where the hurricane has landfall. The sort of damage that we're talking about would be to the power grid, essentially on a continental scale and perhaps on a planetary scale. And because everything else is dependent on electric power supply, almost every other critical infrastructure will experience either immediate or eventual collapse. Now, that would mean loss of potable water within a matter of just a couple of hours for major population centers. Loss of perishable foods, again, within a matter of a few hours. Transportation, fuel pumping, sewage treatment, sewage pumping systems that no longer are able to work and supply as they normally would be. If this happens